Hey everybody, and welcome to another video. My name is Elric, and in this video we're going to talk about first and last value, not just the Windows function, but how do we get in a block of data the first entrance for something and the last entrance for something. Self-joins, first value and last value Windows function, and a third custom solution is what we'll be taking a look at today to see which is more performant. So I hope you enjoy, and I will see you soon. Alrighty, so I'm going to go over what's in the dataset and how I build it before we talk about these solutions, just so we get the feel of what kind of data are we working with. So I found this kind of question, problem, whatever on Reddit, and I decided to make a little optimization piece on it. The data is pretty simple. We have these name IDs where a person has a score on a specific date, but they only have one score per date. And it always increments. So for name 1, score 19, if we ever see name 1 again, the score will be greater than 19 for a different day. So all in total, there are about 17,576 names in here. So that is the number of records we want returned for our three possible solutions. And we want to take one name and find out what's the minimum date they had a score on, and that minimum score, and the maximum date they had a score on, and that maximum score. So how I generated this data is pretty simple. I created a table similar to the data that was provided. There are only 7 records in the data that was provided, so I had to extrapolate what actual data set or data it was referring to. But then I have my default covering indexes, non-clustered primary key, clustered on the names and dates, and my covering, which are names and anything but the names, dates, anything but the dates, etc. So I started at the year 2000, and instead of the single letter names that were in the original data set, I did 3-letter initials to kind of give more randomization. So I did a random number between 0 and 25, and then added 97 and made that like the char, which will give me a lowercase a for 97 and a lowercase z for 122. So that will create my random 3-letter initials. See if the name is in the names table. If not, insert it, and then get the ID. Random score increments of 0 to 20. Get the previous score for the most recent item. If it's not available, then it's going to be whatever we generated plus 0. And then I made, should I increment the date, which is just 3 flags, total of 8 possibilities with 1 positive saying that, yes, we should add a day to the date that we're randomly generating. And because of that, one person, one score, one day type scenario, I said, hey, is the name I have right now also on the same date already in my NameScoreDate data? If not, go ahead, insert the value and increment, or don't do either and just reprocess so we can get 250,000 records, which is a pretty good data set to run these tests. So let's look at the self-join. So self-join, pretty simple. One of the answers that was provided was a min-max with the names, and then you would rejoin the name score twice to get the min records and the max records. So when we run this, we do get our 17,576 records that we were looking for. When we get some pretty high reads, 570,000, a couple of scans, not so bad, but we see the CPU time, 718, is greater than the elapsed time, 252. So this took more resources than time it actually needed to process. And if you're wondering how that works, well, it's parallelism. So SQL is actually taking this code, this query, and putting it on multiple threads to process faster, which is really cool, except for, it's taking more of those resources. So let's see if we can find a better solution. So I'll just go back to the query and have, come on now. There we go. This down here. So the next answer that I saw in this particular question was the last value, first value window function. Unfortunately, in the last value, first value window functions, you need to either add a group by or a distinct, which will be the same execution plan because you will get lots of duplicate data and we're looking for a distinct set. And because I know the Windows function is going to perform better if it had that unique name table, unique data set, I went ahead and said from this data set, but used their CTE with their first value, last value. Go ahead and run this. We still get our pretty high logical reads, but compared to the previous self-join, our logical reads on the NameScoreDate is actually half, and we're still doing parallel processing. So that's pretty good. Elapsed time 239. I think we're kind of in the same range. Yeah, plus minus 30 milliseconds, not so bad. 658, 703, plus minus 50 milliseconds, not so bad. Because the more we do this, we'll get a variance. So we're not going to stick to those 50s so closely. But for a final answer, I went ahead and designed this query, which does the same thing. We start from the names, and we cross-apply the name score data where the dates are in the minimum dates for that person. Now, unlike an inner join, cross-apply allows you to pass values from the data set above into its subquery. Inner join does not. As you can see, it's red right here. But cross-apply does. So basically what we're doing is we're creating a very tiny data set and a smaller data set or a larger data set for this cross-apply before we join to our distinct names. So if I run this, this becomes the better solution. Not only have we dropped our reads dramatically, not even near 570,000 that we had both in the window function and in the self-join, but it doesn't look like we need to parallel process because we are lower than that, lower in the CPU time than it required. So this is very resource light, and they all kind of finish more or less the same. So 260, 240, 228, 171. So actually, this might be faster because it's going down even lower. So I just wanted to go ahead and go over that quick optimization tip. If you have any self-joins, you might want to consider converting them to something like this, especially in that specific situation where you're looking for the first and last in a session and cumulative results or anything that kind of models that problem. So I hope you enjoy. Thank you very much for watching. Like, comment, subscribe. Good luck, have fun, and I will see you in the next video.